Hello, today we are evaluating the limit of this e to the x minus 1 all over 6x squared using L'Hopital's rule. Before we get into L'Hopital's rule, let's just see what happens when we evaluate this limit as is. To do that, we would plug in whatever x is approaching, which is 0, wherever we see x up here. Doing that right now, we get e to the 0 minus 0 minus 1 all over 6 times 0 squared. That gives us e to the 0, anything to the 0 is 1. Minus 0 minus 1, all over 0. 1 minus 1 is just 0 over 0. This is undefined, right? 0 over 0. So now is when L'Hopital's rule kicks in. L'Hopital's rule tells us that the limit as x approaches this number is going to be the same thing as the derivative of this whole numerator divided by the derivative of this whole denominator. So let's go ahead and give that a try. The limit as x approaches 0, it looks like x70. Let's actually draw an arrow. Okay, the derivative with respect to x of e to the x minus 1 all over the derivative with respect to x of the denominator, 6x squared. Let's take each of these derivatives. The derivative of e to the x, let's not forget our limit as x approaches 0. The derivative of e to the x is just e to the x. So let's start with that. The derivative of minus x is going to be minus 1. The derivative of any constant, minus 1, is just 0. So that's it for the derivative of the numerator, all over the derivative of 6x squared. To take that derivative, you're going to bring this exponent down, leave the constant, leave the variable, and then take whatever exponent you started with, minus 1. That's going to end up as your derivative. 2 times 6 is 12. X to the 2 minus 1 is just x to the 1, so 12x is our derivative of the denominator. Now we have a limit again of the derivative over the derivative, so let's try to evaluate. Let's plug in 0 wherever we see x. E to the 0 minus 1 over 12 times 0. Again, e to the 0, anything to the 0 is just 1. Minus that 1 all over 0. Well, 1 minus 1 is 0, so we have 0 over 0 again. This is the problem where we're just going to do L'Hopital's rule as many times as we need to get to this answer. If this was our original problem, instead of this problem, we would do what we did exactly before. Evaluate the limit as is, see that it's undefined, and use L'Hopital's rule. So let's just do that again. All right, so the limit as x approaches 0 of the numerator's derivative, so derivative with respect to x, e to the x minus 1, all over the derivative with respect to x of the denominator, 12x, right? This is going to be a little bit easier. We've done most of this already. The derivative of e to the x is just e to the x. Derivative of a constant is 0, so that's it for the numerator, all over the derivative of 12x. Well, we know the derivative of x is just 1 times that constant is just going to stay. So this derivative is looking like e to the x over 12. Let's evaluate the limit then as x approaches 0. Plugging in 0 where we see that 1x here. E to the 0 or anything to the 0 is just 1 over 12. So that's going to be our answer. The limit as x approaches 0, e to the x minus 1 over 6x squared is going to equal 1 over 12, and we used L'Hopital's rule to get there. If you have any questions about any of the derivatives you saw here, L'Hopital's rule, exponents, e, whatever, please leave a comment. I will do my best to make more videos explaining those questions. If you found this video helpful, please give me a like, send to your friends, maybe they'll get some help out of this as well, and subscribe for more help with Mathy. Thanks!